Okay, so just before we start, Brock, can you hear me?
I,
Are we live? Awesome. So, hello everyone, and welcome to the Web3 Devs Underground. My name is Amit Shilo, and I'm managing our wonderful community alongside our amazing team of volunteers and supporters. We are honored to welcome you all today. Before we dive in with our amazing guest today, I would like to briefly introduce you to our community and to those joining for the first time. Um, so, um, Before we dive in, um, let me start with introducing our community. So, we are the Web3 Devs Underground. We're a group of Web3 developers and builders founded on open source values by Shauli Rejwan and Roy Yosherov. Since we have started 3 years ago, we have consistently hosted in person and online events, bringing together some of the brightest technical minds in the space. We are committed to delivering top tier technical content to the global Web3 community, and we're thrilled to have you all with us today. To stay in the loop for future events and updates, please join our main group on Telegram, and I encourage you to follow and subscribe to all our platforms. We're active on Luma, Meetup.com, X, YouTube, and LinkedIn. You can also find everything on our website at web3devs.org or by scanning the QR code on the top of the screen. A special thanks to our community sponsor, MasterKey VC, an early stage venture capital firm focused on infrastructure and deep tech across the Web3 ecosystem, with a team of 16 world class cryptographers and several technical experts, led by our managing partner, Shauli Redwan. MasterKey operates across all major crypto hubs. And now, without further ado, I am honored to pass the mic to our esteemed speaker of today. Please welcome Brock Hugen, the founder and CEO of the Indexing Company. Brock is joining us today to teach us about indexing data, how it is used in Web3, and share insight on how superior data infrastructure transform payment systems and how to build solutions powered by real-time blockchain data. So, Brock, thank you for joining us today.
yeah, thanks for having me. Excited to be here.
Okay, so let's start with hearing a little bit about you. I would love if you can introduce yourself to the community. And yeah, the stage is yours.
All sounds great. Um, yeah, welcome everyone. Uh, Figured do a little bit of show and tell today, so that's why you're seeing the whole browser tab. But yeah, I'm Brock. I am, I don't know, CEO founder here at what we call the Indexing Company. Um, Naming things is not a strong suit of mine, so just went super literal. But my background, I have been building startups, data infrastructure for over a decade now. Travel industry, real estate, different verticals, but somehow always ended up on the data side of things. Fell into the crypto Web3 rabbit hole in 2017. So back in the ICO days, yonder years. And yeah, was indexing Ethereum at the time. It was pretty much the only thing to track data on, but was doing it there. This was like, yeah, the CryptoKitties days, all the early NFTs when standards were just getting started. From there, was at Coinbase for a while, so kind of saw the other end of that spectrum. A lot of in-house data, interacting with these public ledgers, but still having private sides of that as well. So multiple sides of that data. Then yeah, after Coinbase, started the indexing company, and fast forward a few years, here we are. Yeah.
Okay, awesome. Thank you, Brock. So um, I would like if you can start with telling us a little bit about what's indexing, um, and just giving us the general context of what we need to understand before we start to dive into the real tech behind everything.
Absolutely. Yeah. Teeing me up nicely here. So, uh, at Indexing Co., we build data infrastructure that's faster, cheaper, and more scalable than building in house. Um, what that practically means, a little more visual here. And sorry if this feels a little salesy, it's just the easy slide to pull in. Most of the time, and we'll get into why. data infrastructure starts to look something like the left for a company. You're pulling data from multiple sources. You're doing a lot of transformations. You're processing that data. You have different stakeholders, different products you might be powering from the same data sets, whatever it might be. And so what you end up with is this complex giant sort of organism, if you will, within your company that's underpinning many of your products, and you don't really want to think about it. Most people treat it as a black box. So Index & Co, short version of it is we let it be a black box. We just, from all the years experience and working with so many different companies, we take all that complexity, put it into what we call the neighborhood. So it's compute that you can use to do all these things, but you don't have to worry about what's happening under the hood. And yeah, kind of jumping ahead. Can get into why we're here, everything else, but I don't know, jump in anytime. Did the intro, kind of saw a little bit on Index & Co, but I think the second piece of your question there, why are we here? So bear with me for a minute, but I would say a payment is the process of making value usable. So you can hold money in your hand, you can hold crypto in your wallet. The payment is the transition where you're actually using that for something. That's kind of the definition I like to start from. Looping this back around to what we do, I like to think of indexing as the process of making information usable. So you can have information on a blockchain, you could have a ledger, you could have a database, whatever it might be. Indexing is the process of making that easier or usable in some fashion. So you start to put all this together and why we're here. Crypto is often called programmable, programmable money, programmable payments in this case. And when you start to get into that frame of mind, the data really is the value. That's the thing you're holding. You're actually holding data, state on a ledger, moving that value, doing a payment is moving that data in some fashion. And so you can kind of then loop all the way around to our title here, why better data leads to better payments. And that's sort of the giant overview, if you will.
Okay, awesome. And then, like, in simple terms, what is the like general use of indexing today in Web 2 compared to how it is in Web 3?
Yeah, as a term in Web 2, it's generally thought of as like database indexes or some really small layer where you are taking a set of data and making it more searchable. You think of like search indexes, Google being a great example. That's generally how it's thought of in Web 2. Web 3 and crypto, you have this unique opportunity for open data. These blockchains are public, that data is out there, but they're all constructed with essentially storage in mind. Blockchains aren't meant to be read from in any performant way. They're not meant to be used for building products. And so in order to make sense of any of that open public data, you need to be taking that data in, processing it in some way, and then either serving it to a front end, throwing it into a database, passing it through queuing systems, whatever it might be. But the point is the blockchain data in its starting form isn't ready to be used.
Okay, awesome. And what good example of indexing data you can give us to kind of wrap our heads around it better?
Yeah, absolutely. So if we jump ahead kind of over to here, there's there within the programmable payments concept, that really means complexity. So you have things like bridging, swapping, ramps. Payments becomes this concept that we facilitate with distributed ledgers. And so if we were to look at, say, a example transaction on Relay, make sure I'm still screen sharing here. Yeah. Look at this. So for those that don't know, relay.link is a swapping and bridging service where you can provide an asset, you get a different asset on the other side. Whether that's on the same chain or not, same token or not, doesn't really matter as far as Relay is concerned. They figured it out underneath. And they are doing this with a system of solvers and an intent network. We could get into all those details if we want. But the high level thought here is they are linking two different transactions on two different chains to construct the overall structure here of what we might call a payment, where somebody is sending Ethereum on Base to Sol on Solana. You're ending up with different transactions on different chains, different ledgers. And the only way to make sense of all of this is to have been indexing those two chains, decoding the data, and then putting it into some sort of database, UI, whatever you want to call it, that an end user can make sense of.
Okay, and how does the UI looks at the end, or the indexing itself? How, like this? What we're seeing here is the UI of the transaction.
Yeah, so we could dive into these. So if we go look at, say, this first transaction. So this is the base scan block explorer. I'm just kind of going through different web tabs here so other people to follow on. But it also shows the raw data. So what you're actually viewing on chain, if you were to be indexing this, is you just get hexadecimal bytes, a giant string of byte code. You don't really know what it is. And so in order to make sense of that, you then need to decode it. So they have a nifty button here to decode that. You start to get into, okay, this is the input data for the transaction. But even this isn't super usable. Let me zoom in a little bit here. You're getting things like a signature. What's a paymaster? You've got call data, all these different variables. Still, none of it levels up to what is a payment. There's also, because we're in the EVM landscape, there are logs that get emitted by executing this. So you end up with a log like a relay native deposit. And again, this starts as hexadecimal code. You could, if you knew what to expect, you could decode that into the different values. But really, if you wanted to do this in a universal way, you'd have to then go look at the state transitions. So you'd be saying, okay, what was our overview here? This address sent 0.005 ETH to the relay depository. You could find that in the trace transactions as well. So you can see how this lines up here. All that to say, from an indexing perspective and a data perspective, what you're getting on chain is this transaction. That transaction is going to have a lot of hexadecimal fields in the case of EVM. And in order to make sense of it, to process it, to index it, you need to be decoding all of those fields and applying the logic to understand that this trace call involved this value transfer, i.e., that is part of a payment in this case.
Okay, so the indexed part is the name of the type trace address.
So you're looking at the logs here.
Yes, just to understand where is the indexed part, like to kind of understand it a little bit simpler.
Yeah. So the way this would typically work for EVM specifically, if you are building an indexing solution, you're going to be looking at the transaction objects of a block. So this is that overview, but they come with all of that raw hexadecimal data in here. And they will also have traces. And so if you are looking at the traces in this case, you can see this value transfer on the trace data itself. And this is then what you could index and put into a UI like this. So you can see this is that same value.
Okay, cool. And what is the advantages of indexing it aside from easier search?
Um, it's frankly the only way to make any sense of it. So this is blockchains were designed to keep a global state of the world and a source of truth. So we could send that transaction and never index it at an app level. And your balance, if you ask the chain, will have been updated with that transfer. But you can't tangibly see it anywhere. It wouldn't be in your wallet. It wouldn't be in a browser like this or a block explorer. In order to actually make any of this usable for humans, you must index that data to actually make it searchable, to make it usable, decode all the values. Yeah,
Okay. So it's basically the first layer between the transaction itself and the humans viewing it later.
exactly. It's indexing isn't a requirement for blockchains to operate, but indexing is a requirement to make blockchains usable.
Okay, awesome. And are there different indexing like methodologies for different chains, or is it something that's relevant for every chain in a similar way?
There are yes and yes. So there's if you look at say we do a brief look at EVM chains like Ethereum base as one set, SVM chains like Solana as another, UTXO chains like Bitcoin as a third set. Um, these are all blockchains, meaning from an indexing perspective, you are looking at blocks of data as they come in. So there's some common patterns there where you can track, do I have the latest block? Do I have the most recent transactions? When I get that block of data, let me make sure I loop through all the transactions, do all the processing that I want. There's some like basic architectural paradigms you can do with that regard. Um, from as soon as you go a layer deeper, though, decoding this information into any unified form gets really tricky. Um, for instance, yes, EVM chains have logs and traces. Solana chains do not. They just have messages and instruction data. So it's a totally different structure, totally different part of the data that you have to deconstruct. You're using base 58 instead of base 64, so literally a different decoding mechanism. UTXO chains get even crazier because you could have multiple inputs and multiple outputs for the same transaction, versus EVM and SVM, it's a from and a to. UTXO makes both of those a many to many relationship. So yeah, circling all the way back, there's architecturally, you can design a system that could index any chain as long as it's keeping track with the latest block number, making sure it's running the operations under the hood and keeping up to date with everything. But those operations themselves are going to have to be different for every chain you index.
Okay. About like this part you said to find the latest block, what makes it hard? Let's say in different chains, if you can dive a little bit into that.
Yeah, I'm trying to think of the best way to look at this. So if we go,
We can take Ethereum as a simple example.
yeah, yeah. I was trying to think of a good way to view multiple at once, but maybe we just go one at a time. So if we're already on base. You can see here that they have a concept of blocks, their latest blocks, and these are sequentially numbered. So you go 2.4, 2.5, 2.6, 2.7. Most EVM chains also have a predictable block time. So you could expect for base there to be a block every 2 seconds. And if there's not, either something went wrong with base or something went wrong with your indexer. So you can it's a pretty good heartbeat, if you will, for the chain. If you start to look at a SVM chain, let's see, best way to view this is blockchain blocks. they have what's called a slot number and a block height. So on an SVM chain, let's see if there's an example here. Yeah, here we go. So there was a block at slot 370 and a block at slot 384. In other words, on Solana, you are wanting to make sure you always have the latest slot. You've always processed it, but not every slot will have a block. So you're now keeping track of two different numbers as well, and having to understand that. If you get into chains like Ton, like Telegram chain, it's also sharded. So now you're not only keeping track of one chain, but it's almost one chain with sub chains underneath it, and you need to keep track of the individual block heights, make sure that you're matching them up so that they're always up to date, even though those numbers will be different.
Okay, that sounds much harder.
Yeah, and this is just for making sure you have the latest block number. This isn't even like getting into the actual data underneath.
Okay, and if you get the wrong block number, which means basically you took a block that's not the latest one, what basically happens? You're indexing the wrong number and you're kind of mixing it on.
Yeah, it depends on how you. This is where it starts to get to the nitty gritty of your personal or your company's architecture, if you will. There are cases where we'll look at, say, Polygon as an example here, and the classic case would be a reorg. So a reorg on a blockchain is that the collective nodes that operate the chain have decided that the blocks you thought were the tip of the chain are actually going to be reordered because there's a different segment of the chain that moves further along. And so we call this a reorg. You're reorganizing all the transactions into new blocks. Sometimes that causes transactions to fail. And so as if you're indexing this data, you have to be constantly tracking not only do I have the latest block, but has that block been reordered or reorged? And if so, I need to roll back my system to then go forward again.
And is that something that's common? Like, how common is that to happen in different blockchains? Is it something that's happening or very rare? Like,
yeah, so it depends on the latency that you want to track things. So if we're talking about payments where it's hyper low latency, you could actually be seeing live reorgs. This is part of the consensus mechanism of blockchains. It's generally intended for a lot of chains, not all, but a lot will have multiple nodes produce blocks in parallel. And so naturally, not all blocks will get accepted because there would be two with the same number. And so as you're indexing, you might have received the one that doesn't get accepted by the majority first, and then you get the one that is accepted by the majority after. So yes, if you're doing this ultra low latency, you want sub-second processing, you're going to be getting reorgs constantly, like multiple a minute. If you're running a Block Explorer where you can deal with some latency, like Polygon Scan here, they're saying it's been 21 days since the last reorg, which probably means that they're sitting a few blocks behind just so they don't have to deal with this. It's like intentionally adding some delay to the processing.
okay, so the adding delay to the processing is one way to mitigate this problem. What other ways, by the way, are there for like super fast blockchains?
Yeah,
I guess that they need it the most.
yeah. So we'll keep picking on EVM here just because it's such the common case. But yes, sitting there's this concept of finality and confirmations with blockchains as well. And so if you sit or delay your processing behind the finality mark, you can be sure that no data behind that will be reordered, so you don't have to build a system around it. You can also get practical finality on the vast majority of chains if you sit just one block behind. So what that really means is adding, say, 2-second delay for most chains. Yeah, something like Solana that is also about 2 seconds. If you want to get ultra low latency, though, you need to be tracking the block hashes themselves. So if we look at this is a reorged block on Polygon. You'll see that it has a block hash and it has a parent hash. So this is the important thing. When constructing a chain of blocks, a blockchain, each block will be aware of the block prior to it, the parent hash, and its current hash. And so the way to detect a reorg is if you get a block that, so if this is block, what are we at? 4919, you might get block 4920 come in where its parent hash doesn't match this one. So you've now broken that chain and you know that at least one of those blocks reorged. And so this is where you can start to then roll back the chain and step backwards until you make sure you have a complete chain of hashes to parent hash.
Okay, that's interesting.
Yeah.
So this thing helps you guys, let's say, find reorgs as well, when you can see like at least where to look, because like one of them doesn't match the parent or the current hash. So okay, awesome.
Exactly. It's when done well, you're effectively mimicking what the blockchain itself is doing to reach consensus state. Yeah.
Okay, awesome.
Yeah.
Continue to say. I'll stop with questions if I think anything needs clarifying. Thank you.
No, please. This is great. Most of what I wanted to do here was just walk through examples, so this is right on target. What did I have in my notes if we go back? Oh, sort of zooming out a little bit. Why does any of this matter? So we've been talking about like the details of all this data, how you track it, how you index it, how you process it. This, I think, is a decent view into why the how of indexing is important. So this is a dashboard put out by, excuse me, Allium and Visa jointly, looking at the stablecoin transaction volume. So this is across, looks like they have about a dozen chains, all the top stablecoins, and you'll notice they have a few different things here. So one, they're obviously showing what they call adjusted volume. So this is transaction volume, presumably measured in USD. So already there's some assumptions here. They are tracking stable coins denominated in US dollar. They may or may not be pegging those stable coins exactly to $1. Or to be more accurate, they might have to price them because you could have a stable coin that's actually 0.999 or 1.001. They drift slightly by design. Where you get that data is a whole other question. We'll set that aside for a minute. But so they're pricing all these transactions. They're coming up with an aggregate volume, and so they're showing, for instance, that looks like this is by month. It's like October of last year, 1.48 trillion in stablecoin volume. But note how they're saying adjusted versus unadjusted. So if we toggle over to unadjusted, it looks like stablecoin volume actually peaked way back in DeFi summer, or this is actually December, so December of 2021. And the current volumes are tiny by comparison. What they're doing under the hood here is looking at all the volumes and deciding by some logic, I believe they have a link out to the methodology, but deciding what volume of transactions is actually effectively wash trades. So market making in some capacity, essentially movement of funds that isn't for an end goal other than just to continue moving funds around. Um, long-winded way of saying this is why how you decode the data, understand the data, make decisions on the data really matters. Because you might say, oh, stablecoin volume is actually plummeting, but if you are trying to make sense of it, you can actually see there's a pretty healthy growth curve here.
Can you explain a little bit more
Yeah,
about the differences between adjusted and unadjusted and what it means?
absolutely. So if I'll even click into their methodology here. So for instance, they are uh, categorizing flows of funds. So they're saying they're able to identify which funds on chain map to a centralized exchange, a decentralized exchange. Um, from that, they're also looking at, okay, maybe this volume was actually just Coinbase and Binance rebalancing their liquidity pools. So it's
Mm.
not necessarily a flow of funds, if you will, in a traditional payment sense, but from an on-chain ledgering perspective, yes, those assets did move.
So the unadjusted can be super inflated just because of like internal movements.
Exactly. And that's just one example. Another classic one, saw this a lot with NFTs, where the you would get bots that would just trade the NFTs back and forth to try to slowly pump up the price.
Mm.
So they're creating this volume, making it look like this is a super popular project. Uh, this happens with tokens as well. We just call those market makers. So they're creating liquidity and helping to stabilize the flow of funds, but they do that by just moving funds around.
Okay,
Yeah.
that's cool. Interesting perspective.
Yeah. Yeah, it's not yeah, bots have their time and place, absolutely.
Okay, so I think I understand what's the differences between unadjusted and adjusted. Um, and generally the methodology is to how can they actually understand that though? It's intelligence they need to gather. It's like how can I see if it's Coinbase rebalancing or someone else rebalancing compared to just like money that naturally moves.
Yeah, so this is where you start to apply it's no longer just about indexing raw data into just a decoded state. It's then applying business logic. So in this case, Allium and Visa are taking a stance and getting information from somewhere that a set of addresses on chain belong to Coinbase. On chain, there's no actual marker. There's no way to actually get that from the open data. But you could imagine that, hey, we asked Coinbase, maybe Coinbase made some of that public. And so they have this set of addresses that they identify as Coinbase. They could do the same for Binance, whatever it might be. They create this off chain label set where they can say, okay, these are all the addresses that we know of. These are their labels, these are their tags. Then they can start to do insights on the flow of funds between those. And it may even be that they don't not only is it about direct transfers, but it could also be indirect. So they could be looking at, okay, what was the flow of funds just from like Coinbase to a swap pool to Binance or Coinbase to swap pool and back? That may be something they want to exclude as well.
Okay, that's interesting.
Yeah.
Awesome. We can go back to, to where we stopped last time.
No, this is great. Yeah, I'm just jumping around. So keep asking questions. Hopefully this is helpful for everyone listening.
Yeah, I'm
Um,
doing my best.
good. Um, but yeah, this is kind of getting all the way back around to what we were talking earlier. Payments on chain are programmable payments. That really means complexity. We've been looking at some examples of this where a payment from a user perspective, you want to receive Solana, I want to send Ethereum. That requires a swap, a bridge. You can imagine cases where I want to send my friend money on Venmo. He doesn't want crypto though, so now I need to do an off-ramping move in some fashion. It's really complex. Um, as a concept, payments is essentially something that we facilitate with these distributed ledgers. So we have the data out there as far as the state of the world. At this point in time, Alice had $5, Bob had $10. You go forward in time, and now Alice has $10 and Bob has 5. You can mark that as a transfer. These are the building blocks, if you will, for how we construct something like a payment. Yeah, we've already walked through Relay a little bit. Also, I wanted to gut check. How are we doing on time?
Just continue as much
Okay.
as you want. We have
Okay.
time as long as people are still interested in what we're doing, so it's good.
Beautiful. Okay. I'll let you keep me honest on as long as people are interested. Otherwise, I can ramble for a while. Um, yes. So we were looking at some examples. Relay was one that we had looked at briefly. So this is imagine this is that payment use case where you want to receive Solana. I want to send ETH from base. Um, Under the hood, this is updating two different ledgers, the base ledger, the Solana ledger. You have to index both of those and combine them in some meaningful way to present the user with the concept of a payment here. Where are we at? Close that. Another one that's potentially interesting to look at. Polymarket is huge, blowing up. The way they do deposits, so getting assets on Polymarket, is another sort of interesting use case. You can imagine from a data perspective, a deposit effectively is a payment, just labeled differently for users. In data, identical. And so Polymarket, I'm going to work backwards here. They only want to have USDC.E on Polygon. It's the only thing you can transact with on Polymarket. So when you sign up for an account, you get an address that's part of your Polymarket account that will hold this USDC, and that's what you trade with. A lot of people don't have a USDC on Polygon though. So in order to get it there, they have this deposit flow in partnership with fund.xyz. And so the way this works, if we go all the way back to the beginning, this is me depositing funds into Polymarket, sort of as a test. Where do we start? Started on Solana. So you can see this is me, it's my handle. I wanted to use the Solana I had on Polymarket. Polymarket can only use USDC on Polygon. And so they present this deposit flow where I send Sol or Solana to a deposit address. So this is an address that FundXYZ controls. I move the funds there. And you'll see this is at 10:26:01 UTC. The next transaction then, this is about 17 seconds later, FundXYZ is sending the funds further along. So they're taking that SOL that I sent the address. They are then doing a sponsored transaction. I'll circle back to that, but they are taking that Solana, they're sending it to the Jupiter aggregator to eventually swap it into USDC. So the funds have moved from me on Solana as Sol to a holding account as Sol on Solana. And then now Fund has gone and taken the Sol, swapped it to USDC, and put it back in the holding account. The final step of this is they are also then transferring the USDC from the holding account to Relay. You can see how these building blocks are starting to build up now. The Relay is going to receive USDC and do the bridging over to Polygon, where you now see this. About 8 seconds later, you get a transaction on this chain depositing the USDC into that Polymarket address. 3 different transactions, 2 different chains, 3 different assets, all one flow as far as the user is concerned.
Okay, awesome. And is there a difference, like a noticeable difference in the process when you're doing this using fiat? Let's say I'm paying with credit card. How will this flow look?
Yeah, so this is the short version is the collective we don't get to see it. So the beauty of crypto rails is that it's open data and we're able to introspect it in this way. If you were to pay with a credit card, that goes through something called VisaNet, for instance, if it's a Visa card. Totally private ledgering system, not a blockchain, but ledgering system that Visa controls. And if you wanted to see what's happening, you would have to ask Visa. There's no way for the rest of us to actually access that data.
So only after going on chain we'll be able to inspect anything from this process.
Exactly.
So from the moment someone exchanges it to, let's say, USDT or whatever.
Yep.
Yeah, USDC. Okay, awesome.
And it even gets exchanges make this even more unique, is maybe a way to put it. Robinhood, Coinbase, Binance, there are flows where you can buy crypto, deposit whatever language they want to use, and they will show you as owning crypto in an account, but not actually move any assets, at least nothing on chain. So it's
found internally inside their systems.
Exactly. And so, for instance, if we were both on Binance and I wanted to send you money, it's highly likely that Binance will just reallocate those funds on their own internal system without moving anything on chain.
It's cheaper and faster, I guess. So yeah.
Exactly.
Okay, awesome.
Yeah.
Okay, I think I get it. You can continue.
Yeah. I think the maybe the meta point there is there's as much as we can track, there are still a lot of sort of black boxes with regards to payments because of the way TradFi and traditional rails work. We don't get insights into those, and so we can only really index, process, display what ends up in this open ledger.
Okay, and the indexing process in Web2 is similar to what Binance is doing internally, let's say in this case?
It can be. Yeah, so you zoom out far enough, you could imagine that Binance has an internal ledger where it's a database saying this account has this much money, this account has this much money. Somebody submits a transaction. They don't put it on a chain, but they just facilitate updating those two balances to indicate a transfer. Basically mirrors at the highest level what a blockchain is doing, but because they don't have to share that with anybody, it means they can control the cost completely and they can control the performance completely. There's no need for consensus. There's no need for gas fees. They get full end-to-end control over that.
Okay, it makes the differences a bit clearer.
Yeah.
So it means that basically every major chain needs indexing to help people understand what's going on there and kind of translate everything that's happening on chain to let's say Block Explorer and everyone else.
Yep. Like a semi classic way I like to think about blockchains is as a globally shared database. And so constructed with the priority being to be able to share that data. Comes with a lot of benefits, it's all great, but by prioritizing that, actually using that data becomes an afterthought. And so this is maybe the flip of, say, a Binance's internal system where using the data means everything. Sharing it is a total afterthought. You can kind of see how you end up with different architectures just based on that.
Awesome. I see questions from the audience as well.
Oh, please.
How is the intersection done to transfer an asset from one to chain to another?
Oh, yes. Okay, so in the bridging case, there's a couple. We'll say there's two main models for how bridges work. The sort of first iteration of bridges was a lock and unlock process. So you'd have an operator. This is like a business that is going to say, okay, on chain A, I'm going to hold X amount of funds. And on chain B, I'm also going to hold Y amount of funds. So we have two liquidity pools. And as a user, if I want to move my funds from chain A to chain B, I could send my funds to this provider. They would lock them on chain A and then release them on chain B. This is a very, very classic approach, usually a little slower, usually higher fees. What we see now with the more robust, maybe that's a more complex bridging solutions is they're intent based. So it'll be like an across or a relay where they have a network of market makers. And instead of having to hold liquidity on two sides, they ask their collective network for someone who can facilitate the other side of the transaction. So a user will send, if we go back to this example, at the time that the user deposits these funds into basically into Relay's address, Relay goes out to their network of solvers, is what they call them, and says, hey, this user wants to receive at this address this amount of Solana. Who that is already on Solana can help us facilitate that. They match the two and then facilitate that order. And so they've built up basically instead of having a single liquidity pool as a smart contract on both sides and locking and unlocking funds, they're doing an intent based user submits on this side. We ask our collective network who can facilitate it for maybe the best fees, the lowest latency, whatever the priority is for the ask.
So this is much cheaper and faster, I guess. But
It's definitely definitely much faster. I think the promise is it's much cheaper at times.
but
There,
like, what are the downsides of that? Like, are there any risks associated with operating like that, or?
there's yes. So pros and cons here. Intent-based solvers, you're trusting the off-chain solving solution that say Relay is putting out. So you're blindly sending funds to Relay and trusting that they will either figure out how to get the funds to you on the other side, or they'll return them. But at the time that you send them funds, Relay has full control over them, and there's no actual on-chain guarantees that you would ever get those funds back. You're just sort of blindly sending them out. Of course, they've built up strong systems and have brand trust, all the things. But from a strictly on-chain perspective, there's no actual guarantee that Relay has to do what they say they will do with your funds.
Okay.
Yeah.
That's conceptually, I understand. But practically, are there any cases that you're aware of this being exploited, or?
I haven't seen. So what's funny is actually the traditional bridging solution where you have a smart contract is what I've seen get exploited far more. Um, Primarily because you end up with giant pools of money in a smart contract. So if you can figure out how to get access to the smart contract, you could drain the pool of money altogether. So that's happened. And that's largely why a lot of these intent-based solutions have cropped up now, where liquidity is no longer pooled, and so it sort of distributes that risk, if you will. More of what you see now is perhaps a bad user experience. So this system of intent-based solvers relies on somebody that you don't know to have what you need on the other side. If you are moving $1 million, it's highly likely that somebody on the other side doesn't just have $1 million sitting there and exactly what you need at exactly that time. So you might be stuck or need to do it in smaller transactions or whatever it is. My opinion, at least, is that the intent-based solvers are great for payments, smaller flows of funds, more peer-to-peer or B2C type or C2B type operations. Whereas the more traditional bridging and market makers in that sense are far more useful for large volume transfers.
Okay, yeah, makes sense.
Um, What else did I have? Yeah, so we talked about Relay, Polymarket, CFI, DeFi. Only other example I was trying to dig into from a data perspective is tempo and memos and how even within a particular ecosystem you can get drift. So uh, diving into that a little deeper. This is base again. We'll go just look at the latest transactions. Let's look for let's find a transfer. There we go. So this is no, it's a very standard transfer. Apologies. Usually there's just a ton of stablecoin transfers. Here we go. Okay. So this is a massive transaction. There were 22 ERC20 token transfers, and even an NFT transferred throughout this. So this is just a big transaction. Even Etherscan or BaseScan doesn't really know what they were doing in aggregate, but you can see all the individual pieces. What I wanted to call out here is from a indexing perspective and trying to track all of this. The ERC20 standard, for those that are aware, has a very predictable, standardized event log that you can listen to. So it emits on every transfer this transfer log where it says it has a from, a to value, or from, to, and a value, so you can see the amount. And the contract address is the one that's emitting this log. So it gives you a pretty clean way to track transfers for a given token. You code these logs, very predictable. All ERC20s effectively support this. What starts to get interesting, though, is there's a whole bunch of random edge cases. So, for instance, Tempo, those that aren't aware, this is Stripe's new blockchain specifically suited for payments. They took the ERC20 standard, which was meant for tokens facilitating that transfer, and they took it one step further by adding a memo field. It doesn't sound like much, but I'm calling this out because from a data standpoint, you're now going to have drift. So you have the ERC20 transfer, and you have what they're calling a TIP20 standard. And so a TIP20, if we go down here, you could still call your normal transfer function like an ERC20, but you could also transfer with memo. So you're quite literally adding an extra field on chain during this. So now this is a new thing. In the best case, this is net new data that you could ingest, you could present to users, you could use for whatever you need. At worst, this could turn into some tokens no longer implementing the well-known ERC20 version of this and only implementing this, which would actually break a lot of systems. And so you have to, not only when you're decoding all this data, not only do you have to decode the standards, but you have to be aware of basically forks to those standards.
Why would it break it, by the way? Because just an extra data point. Can't you just get rid of it and mitigate it?
So the way most decoders work, let me see if I can find a good example of this. If we go back to base, because it's easier to view here, this transfer log had, can I view it? All right, I'm not going to get a super clean view here, but the short version is the data for this log comes as one hexadecimal string, and the only way to know its parts is by separately being aware of this structure. An important piece here is, so you have to know that it's supposed to be three fields in order to pull out three fields.
Okay, and from the string, I can't understand that.
Correct. There are ways to guess at it. For instance, EVM world, the first topic is always the hash of the event log signature. So this is like a SHA-256 hash of this whole value. And so you could say, okay, if I see this, I can assume that it's supposed to be this transfer because it's a one-way hash. But then you don't get to pick up. Basically, that would give you a way to ignore, say, the TIP20 transfers. But it's highly likely that you actually want to support both.
Okay, and to support both, you need to actually decode it in two different methods. So it
Exactly.
double the work, but yeah.
Yep.
Okay, and how like extend like how hard it is to work on that? So compared to just doing one method, is it actually slowing down things? Is it something that's easy?
Yeah, computationally, it's actually very easy. Honestly, the 99% of the effort is just even being aware that this is a thing. Like, there's no global registry, there's no way to know. So for the most part, you find out about these fun changes because something breaks or a user complains. Um, yeah, sort of a sucky answer, but the actual computation of it is relatively simple.
Okay, so for anyone in the audience that's indexing data, this is something to remember. If something breaks in this aspect, maybe it's TIP 20, no, not just ERC20.
Yep.
Okay, awesome.
Yeah. Um, I think, yeah, I was just gonna, I have a couple more slides, but then I can wrap up here and take any questions. But yeah, sort of summarizing all of this. Uh, Payments as a concept is something we in Web3 are facilitating with this open data, these distributed ledgers, to make payments useful for users and businesses. Not only do we need that on-chain data, we also need a bunch of other things we were talking about. So token metadata, what are the symbols, what are the pricing, what are the labeling, like was this transaction from Coinbase? You might have compliance checks, like is this address actually on a sanctions list because it's known to be a bad actor? You to get a full picture, you actually start integrating a bunch of data that may or may not be on chain. Say all that. So this is typically how indexing infrastructure starts to look. So this is Optimism's internal data stack to index all the Optimism's chains. And this is not a knock, by the way. This is a very solid architecture. They clearly thought a lot about it. This is just the complexity that comes in with this much data. So they're getting on-chain data. They're working with third parties that are sourcing off-chain data like labels and prices. They're pumping that into some raw layer like Google Cloud in this case. Then on to ClickHouse. Then on to further processing for things like they want to show transaction volume or they want to generate a report for the revenue of their chains. So you can see it's all multi-layered, multifaceted. You end up with these crazy architecture diagrams, and this is just the overview of it. Point is, this is all hard, and that's okay. So what can we do about it? Yeah, said it a few times, but Web3 only exists because of that open data concept. This data is public. It affords us a lot of opportunities as far as we can actually see when something breaks, or we can see when there's a new standard we weren't aware about in the data itself. Lean into that concept that this is all shared in some way. And so you can kind of treat the data as a friend, not a foe. Another way to frame it is we're all in this together. It's likely that if you're facing a problem, somebody else has as well. So open data, we're all trying to process the same sets of things. So there's a lot of good libraries, a lot of good SDK support, good label data sets, whatever it might be, probably out there. And I think the other important call out here is to not treat data as an afterthought, especially if you're building in Web3. Treat it as sort of almost the entry point to your product, your protocol, whatever it might be. I especially call out protocols here because protocols are the ones generating more data. So you want to think about how you're going to use it on the other side to make sure you're actually generating what you need up front. Yeah, that's me. Happy to answer questions here. Also, feel free to reach out anytime. Yeah.
Awesome. Okay, thank you so much, Brock. I have some questions that I would love to ask
Please.
before we finish, and we'll give the audience a chance to ask here or in the Telegram group. Feel free to send it or in the comments. We can also show them here. Let's start with Danielle. I see she has one question. Okay, so are solvers or providers regulated in some countries? Are they autonomous or controlled manually?
Yes. Not legal advice. Don't take anything from me as such. But yeah, there is a undercurrent of conversations going on, especially driven by fintechs. So there's a lot of fintechs in the space that might want to tap into the liquidity that users already have, i.e., crypto. So you can imagine like gambling platforms, trading platforms, they want to be able to onboard user liquidity. In order to do that, they need to work with partners like Relay. As far as I know, none of them are licensed, is maybe the way to put it. So they will work with the relays of the world. So the individual platforms might try to be regulated and license themselves, but that bridging mechanism, the solvers, the providers, I don't believe there's any that actually have licensing because that would require them to register as a payment processor. So they would have to operate at the same level as, say, a Visa, but we're in crypto. These companies don't have that kind of funding nor that like political clout, if you will, to get what they need to through. Um, so I'm sure they're working on it, but yeah, as far as I know, none of them are actually fully regulated.
Okay, so I'll start with the more technical questions,
Please.
um, and then go to ask a little bit about you as well. So let's start with you mentioned that better data leads to better payments. If you can walk us through a little bit of the biggest bottlenecks in the current indexing infrastructure that slows down payments processing. So yeah, if we can start with
Yeah.
that.
Um, I could do a whole talk on just this, but I think the diving all the way through it and getting to a short answer. I think the biggest problem with payments and indexing today uh, is that companies aren't comfortable handling reorgs. So that logic we were talking about with tracking, did this block change? Did this transaction reorg? Because we're now talking about payments and talking in the context of fintechs and financially regulated institutions, they're risk adverse by nature, by design. And so, because of that, they don't trust their own systems to process reorgs effectively, which means their only real solution is to wait for mathematical finality. So, you'll often see, even if we could practically assume that there won't be a reorg after 1 block or 2 seconds, a lot of times these companies will wait perhaps 30 minutes just to be extra sure. And so you get this massive delay in the processing of the payment as far as the user is concerned, even though it's already happened on chain. Um, this also compounds slightly at the orchestration layer. So like Relay, for instance, has taken a stance of front running transactions. So if we go back to this example, you can actually see these two transactions happen in the exact same second. Two different chains, two different transactions. What this is telling us is that Relay is not even waiting for the transaction on base to be officially there yet before sending out funds. Relay is implicitly taking on that risk of a potential reorg because it provides a better user experience. Fintechs are typically not comfortable with that at all. And so you get this pull and push of user experience versus compliance and regulatory pressure. Yeah.
Okay, thank you. Um, the second question I have is, How do you handle data consistency in and chain reorgs? Well, we kind of answered that. Dealing with real-time payments. Is there a trade-off between speed and finality? I think you already touched this a little bit in the in the discussion, so I'll skip this one. Um, okay, so for developers building payment rails, what are the most common mistakes you see when they design their data architecture?
Yeah, there's a few different ones. So one being not trusting the reorg process or having logic to handle that. So that immediately adds latency. Um, Another classic trap is not tracking all transactions for their users. So there's an attribution problem that a lot of these fintechs have as well, where so we go back to the Polymarket case where we're doing deposits. Polymarket wants USDC. It's plausible Polymarket is only tracking USDC transfers. What this can lead to, I'm not saying that Polymarket does this specifically, but just a company could. If I, as a user, accidentally send USDT, that happened on chain. Polymarket or this hypothetical company has no idea about it, so they're not tracking that transaction. So this is like a classic trap that I see all the time. It's much better to just track every interaction with your users' wallets. And then you can always back into if it was an accidental payment, maybe this needs to be refunded, whatever it might be, and provide a better user experience there. Um, so yeah, reorg handling, track all transactions. And the third one I always like to call out is don't use monotonic IDs in your database or foreign keys. So I don't know why this trips people up every time, but when dealing with blockchains, the data is already sequential from a block number, and it's already uniquely identified by, say, a transaction hash. You don't need to add your own ID on top of all this. As soon as you do, you get drift with the chain. You end up with weird edge cases in your queries where you can't do proper joins. Just use the chain's own identifiers in your data as well, and then you can match everything together pretty easily.
Okay, awesome. I would like to ask a question that I like to ask almost everyone these days, but like, are you using AI in any way in your work today? And like, does it help you? Does it like, yeah.
Yeah, I will say I'm still a major AI skeptic. My whole team uses it. I'm just like the grumpy old man that still does it. It's not for lack of trying though. From what I've seen, AI and LLMs in general, they are built to predict the next token, the next piece of code, the next word, whatever it is, which means that they can only predict things they've seen before. So if you're actually doing anything novel or anything that requires real business logic applied, so like something critical in your systems, it shouldn't be able to help you because it hasn't seen that before. That's sort of like the implicit model there. I think it's great for demos, great for building inspiration, things of that nature. But no, I haven't been able to use it for any like production systems yet.
Okay, yeah, makes sense. Are you using machine learning instead, like, or are you not using it at all?
We haven't yet. It's interesting. For instance, we worked with a block explorer a couple years ago where we were able to still decode 99.9% of transactions using pretty basic heuristics. So I think there's this is pure personal opinion, but I think there's a trend right now where everybody wants to apply AI, but not. I think most problems actually don't require that much intelligence. It's just like get a simple if-else statement going, and you can probably get where you need to.
Yeah, it's like the regular questions. Are you using like
Yeah, yeah,
blockchain, and do you need to use blockchain or not? So,
exactly.
and I
Yes.
guess the same with it goes with AI. So,
Yep.
um,
Exactly.
okay. Few other questions. So, scaling blockchain data is notoriously difficult. What was the hardest production lesson that you learned while scaling your infrastructure?
What? There have been so many. I think we're on like version 7 of our indexing infrastructure ourselves. We, what have we done? A classic one that we ran into super early days with EVM was EVM addresses are hexadecimal strings, and there's a checksum version which will have some uppercases, but you can also safely store them lowercase. They're still unique lowercase. What this means is the data you get from an RPC, for instance, may or may not be checksummed or might be lowercase. And so we like working with that largest where I think we processed 20 the full history for like 25 chains and didn't normalize those addresses to a lowercase version. So you ended up with a database that had mixed casing, and it was almost impossible to actually do any queries against it because you need to know, okay, or you have to either first convert it to lowercase at query time, or yeah, basically that. Long-winded way of saying, yeah, we had to reprocess 25 chains worth of data, so like a couple hundred terabytes, just because of lowercasing addresses on EVM.
Wow.
Yeah.
Um, okay, awesome. So another question is: do you see the future where do you see a future where indexing happens heavily on the client side, I guess light clients, or will it always rely on robust server side indexing for payments? Is it something that you see a change in?
I I'll answer this in two ways. Short answer, yes. I would love to see this move to the light client layer, and I think that's entirely doable. Slightly longer version. This is actually our vision with the Nextchain Hub. We call it the neighborhood, but we've built out a distributed system that does our indexing for us. So these are, you can think of them as nodes that can connect to any blockchain, do any sort of processing, and they're lightweight enough that they could be run in a browser. And so you could imagine scaling this to a point where a fleet of them are deployed in all of your users' browsers, and those nodes are able to interact with each other to co-process and co-share process data. Um, this works really well for real-time data. It's like payments flowing in, net new stuff. The biggest issue you run into is any historical state. So if you want to query, what did I do yesterday? You can't really do that with a traditional light client from an RPC. You're probably going to need to store that in a database somewhere, which is what then it reintroduces a server. So, long-winded way of saying, I think indexing, yes, could happen at the client level, but in order to make the like powerful user experiences, you still need historical state, and that storage layer we haven't figured out how to get to a client level.
Is there like an advantage in doing it client side?
Pros and cons. Yeah, I think the potential pro is if your client is also the one producing the data. So you can imagine like gaming would be a good example of this. We're playing a game. I do an interaction. You need to know about it sooner. If we're connected in a peer-to-peer fashion, and we can do that indexing directly on a shared ledger in some way at the client level, we're going to get that information faster than if we had to go through a server relay.
Like if we're playing an online game together, so
Yep,
basically all the players will be connected, like peer to peer, so it would be faster than sending the information to the server and back.
exactly. Yep. Yeah, so you can imagine a super simple gaming architecture with a blockchain in the middle being everybody, clients and server, are connected to the blockchain. When a new client joins, you ask the server for the historical state, and then you subscribe to new state directly from the chain.
Okay, well, that's
Yeah.
cool. By the way, is it useful for like indexing, um, like other data than what we're talking about in the payment space? Like, can I also index, I don't know, videos, pictures, movements, stuff in gaming? I don't know.
Yeah. Short answer, yes. Longer answer, some of the unifying elements of the architecture, like there being a block, and that block has a set of data, and it's time based, and there's a heartbeat to every chain type of thing. You start to lose that as you move away from blockchains. So if it was something like here's a folder with 100 different video files, you could theoretically use the same computational aspects, but there you lose all the time series elements. So there's not yeah,
It's
I think
more abstract, I guess. But like,
yeah,
just from thinking about like the gaming example, I was like, maybe we can index that, and then small machines can run very heavy things using like indexing
yes.
methods. But like,
Maybe the way to frame it, what I was trying to articulate is you need a different trigger. So blockchains inherently have this trigger by creating a new block, and that's sort of your trigger to go ingest that data, process it, index it. Um, you would just need to build your own trigger for processing, say, in-game elements.
is it somehow similar to how you run games on I don't know, virtual machines and stuff like that? Like I see a lot
Uh,
like in Steam and stuff like that, you can actually run a game inside their system and not.
yeah, so no game expert, so tell you with a grain of sand. But yeah, my understanding is much of what you're running and what is computationally heavy is actually generating the graphics in that case. So creating the world that you're in. And if you're doing something multiplayer, the important aspects are actually the positioning values. So like my character is at XY coordinate, your character is at AB coordinate, and we need to update just those two values between us as fast as possible, and then we can let our client do all the rendering in between.
Mhm. Okay, that's interesting as well.
Yeah,
Um, touches a lot of points. So we got to another interesting part. So I would like to ask you some personal questions about yourself.
yeah,
Let's start with how did you get started in the indexing space? What gap did you see that made you found the indexing company?
yeah. Honestly, I started indexing data accidentally back in 2017. So I was like working. We were trying to bring real
Well,
estate. Yeah, we were, we were trying to bring real estate on chain. It's like tokenized real world assets is what we call it now. Back then, there was no concept of a multi-sig. NFTs hadn't been invented yet, so we were like way in over our heads. So we're building our own smart contracts, trying to basically build up these same primitives without any standards, which then also required us to index that same data off chain. Long-winded way of saying that's how I got started. I was kind of hooked on the data side of all this, really into IPFS, really into this concept of the open data, something that's shareable peer to peer. I don't know, it piqued some sort of interest for me. So yeah, I've been doing that then for a number of startups along the way. Went to Coinbase, and basically after all of that, this is like when the graph was big. Like if the graph is their only solution, and in my opinion, it's architected entirely wrong. We need something else. Nobody else has a commoditized offering, which means every business is building indexing infrastructure in house. So that was kind of the impetus for, all right, I'm ready to try to commoditize this just because I've been working on it for so long. I'm tired of rebuilding the same thing over and over again. I just want to build it once and everyone else can use it. Yeah.
Okay, that's awesome. How did you get into the Web3 space in general? Like, did you get into through indexing or like?
Yeah, so this was 2017. I like fell into software in general. I didn't like go to school for it, didn't mean to do it. Just like was bored on the laptop in school and realized I could make some money. So I was doing a bunch of consulting after school, working with startups. Uh,
What
yeah, I
did you
saw a
study, by
job.
the way?
I ended up with a degree in mathematics, but like the only thing I'm qualified to do is teach mathematics in a high school. So like, yeah, totally
Yeah,
pointless
same
in that
problem
sense.
with physicists, by the way.
Yeah,
But yeah.
yeah, exactly. Um, But yeah, no, so I was like bored doing consulting, and saw a job board where somebody was offering to pay in Ethereum. It's like, I don't know what this is, but sure. So ended up, long story short, that's who I did the real estate startup with. And we worked together on Index Info for a long time as well.
Okay,
Yeah.
that's cool. Um, Next question is, what is the one thing that you are most excited about regarding the future of crypto payments in the next 1 or 2 years?
I am most excited about no longer calling them crypto payments. I think we're like slowly inching towards I don't know, some sort of inflection point here where maybe there will finally be enough adoption by non-crypto native companies that we can just call them payments. That's what I'm most like excited for. Like fully integrated. This is just traditional fintech with better rails.
I can at least personally say that I'm hoping for the same, and looks like we're slowly going in the direction. But yeah, fingers crossed, let's say.
Yeah.
Okay, what is your favorite part of your day-to-day work,
Um,
or least favorite, if you would like to say
yeah.
that? Like,
No, the least favorite is waking up at 2 a.m. because a blockchain stopped. Like they stopped producing blocks, so I got an alert about it. I think the favorite part is genuinely just being able to help people, whether it's customers or not, but just like helping people understand the data, understand this space. It's how I keep learning by just like trying to teach others. Yeah, I don't know. I really enjoy
such a math major, but yeah.
it.
But I'm thanking you for that.
Yeah.
At least I can say for myself, it was really helpful to learn from this talk. So one last tip that you have for developers looking to break into the space, um, in general, or a good
Yeah.
tip that you have for our community.
Um, yeah, I think if you're a developer not already in the space, start playing around. The barrier to entry is remarkably low these days. It used to be that there were no docs. You just like had an RPC that would probably crash on you all the time. Things are actually stable. You can build real products. There's AI integrations to kickstart whatever you're working on. So just play with it is the short version. Um, and yeah, I think that's about it.
Okay, that's awesome.
Yeah,
So, thank you so much, Brock. It was a pleasure.
likewise.
It was a fascinating lecture, and also it was a great to have the chance to ask you so many questions.
Yeah,
So, unless there is any other questions from the audience, and feel free to send them in the comments. I would like to thank all of you for participating today, for everyone who joined. Um, if you like our content and would like us to support us, I would encourage you to join our Telegram, and you too, Brock. We would love to have you there. Maybe to
absolutely.
asking more questions later on. Um, so everyone, feel free to join our Telegram. You can scan the QR on the top of the screen. You have everything about us there. Um, encourage your friends as well. We're a nonprofit. This is like the way to help us grow and continue bringing top content. So please invite your friends and colleagues that you think might be interested in technical entrepreneurship, in the Web3 space, and general technologies that are cool and in our space today. So we're here to help you with learning from the best, connecting, and even help with hiring. So we would love your help, support, and even feedback. So feel free to reach out to us, to me personally. We would love to learn to get better. And yeah, if you would like to take
Yeah,
an active part in the community in any way, um, any of the people watching, feel free to speak with us on the Telegram group or even privately on Telegram. And if any of you would like to speak at one of our next events, please let us know and reach out to us on any of the ways that available to you. And for those listening for the first time, we are the Web3 Devs Underground. We are all about technical content, open source, no shilling content, and all done by builders for builders. So Everything we do is always free, reliable, and for the community. So, thank you again, everyone who joined. I encourage you to follow for next event on our calendar and social media platforms. We will inform you about the next events. I think the next one we have is an academical conference that's happening in Israel. Will be broadcasted as well, but if any of you are here, you're more than invited to talk to us about it. We'll publish it on our Telegram group on and the rest of the socials. And see you at the next one. All the details will be available through the website and also through Luma or the meetup calendars. So thank you again for joining us today, and see you next time. And thank you, Brock. It was amazing.
Likewise. Thank you so much.